Okay, so we have one more type of confidence interval we need to learn for this book, and this one deals with proportions. So this is section 7.3. This is confidence intervals for proportions. So this one uses the central limit theorem again. So again, since we're using the central limit theorem, remember for proportions, the condition we need to check is that this interval, right, p hat minus 3 sigma p hat, and then p hat plus 3 sigma p hat needs to be contained inside of 0, 1. So that's sort of the sample size condition like we had to do in greater or equal to 30 for section 7.1 and section 7.2. We didn't necessarily have a condition we had to check. We just got to use the t-distribution instead. So in order to be able to use this formula, I'm getting ready to write down, just remember you need to first check this sort of sample condition, and we'll go through what these formulas are in our example that we'll do today. And if that's met, so then if that's met, you can create a confidence interval for p hats can be found by doing p hats plus or minus z alpha over 2, and then you use the sample standard deviation sort of thing, p hats 1 minus p hat over n. So that formula should look pretty familiar. That's how we calculated sigma of p hat before, but we don't know p, so we're using p hat in its place, and that's how we'll calculate that portion of the confidence interval, is by using p hat instead of p. So that's pretty much it. If you read this section, it's literally like a page and a half because there's nothing new in terms of concept, it's just a new formula. So I'm going to work number 11 out of the book. If you want to go see what that one is, I'll read it to you. But if you want to see what the question reads, go feel free to take a look at that. Okay, so if you look at number 11, you'll see that in a random sample of 12,447 hip replacement or revision surgery procedures nationwide, 162 of those patients developed a surgical site infection. So that's the starting pieces of this problem. This is number 11 from section 7.3. Okay, so we have 12,447 hip replacement or revision surgeries, and 162 of those got an infection. The first question, letter A, says give a point estimate of the proportion of all patients undergoing a hip surgery procedure who develop a surgical site infection. So they just really want you to calculate what all that means. If you hear all that word, and I think it's in every single one of these questions, is to calculate a p hat. So when they're asking you to give a point estimate of the proportion, all they're really asking for is to calculate p hat. Okay, so in this problem, p hat, right, is a proportion of people that did a certain thing. And in this case, we want the proportion of people who develop an infection. So to develop an infection, remember there were 162 of those people out of 12,447. And if you do that calculation, I got 0.013. So that's p hat. It literally is just a calculation of the sample proportion. Part B, which we'll do on the next page, but I'll go ahead and write here what it wants us to do. It wants us to verify that this sample is sufficiently large to construct a confidence interval for that proportion. So that is the verify the CLT conditions, truthfully, is really what that's saying. So it just wants us to use that interval business with the 3 in it, the 3 p hat plus or minus 3 sigma p hat. That's the thing that we need to check in order to verify the CLT condition. So we're going to do that on the next page. So if you remember, in order to do the verify, we need to use this formula, the p hat plus or minus 3, and then we're going to go ahead and plug in here p hat 1 minus p hat over n. That's the thing that we need to check. So let's go ahead. We have everything we need, I believe. We know that p hat is 0.013, and n from the previous page, remember that's your full sort of set, is 12,447. So we can just plug this in, right? We want to check that and the ultimate goal is to check that this interval will be contained inside of 0, 1, right? That's the ultimate goal. That's the thing we have to check. So first we need to calculate those things, then we need to make a comment about whether or not it's contained in 0, 1. On the exam, some of you calculated the interval, but you didn't actually write out why you calculated it. So don't forget that part of checking the conditions means you actually need to tell me, oh, I noticed that it's between 0 and 1, or write out this symbol that means contained inside of 0, 1. So we're going to go through that whole process now. So we're going to take 0.013, we're going to plus or minus 3 square root of 0.013, and then this would be 0.987, I believe, and that's divided by 12,447. And this number here, if you're trying to figure out where it came from, right, you can come over here and check it out. It's 1 minus 0.013, right? That's the 1 minus p hat, and if you do that, you do get the 0.987. So if you're uncertain about where that number came from, that's what we're talking about. Okay, if you calculate all this, this is 0.013. If you check that square root stuff in your calculator very carefully, I got that to be 0.001. Rounded a little bit. There's a few more decimals after that, but that's pretty close. And so then if you're creating your interval, right, if you do the 0.013 minus 3 times 0.001, and then you do 0.013 plus 3 times 0.001, right, you're going to get this interval here that is 0.01 up to 0.016. Okay, and if you look at that, that is certainly contained between 0 and 1. And so the conditions are met. Okay, so that's really all you have to check. It's a calculation. You're going to take your p hat plus or minus. So you're going to do p hat plus or minus your 3. This right here, right, this is that p hat times 1 minus p hat over n. You take the square root, so that's what this part is. So we have 0.013 plus or minus 3. I did this on the calculator, right? First I did the minus, because the smaller number should go first. Then I did the plus, and then I checked that that whole interval was contained inside 0, 1, and the conditions are met. And in all actuality, if you look at the actual formulas in the book, I guess these should really be square brackets around here, right? Which means we're including those endpoints. So we should probably include those in square brackets here on each of these as well. But this definitely is going to fit inside 0, 1 regardless. So this is part B of the problem. We checked our conditions. Everything was met. And so part C is the interesting and new part that we're actually going to create our confidence interval, and that's what we'll do next. Okay, so this is part C, and part C in the book says construct a 95% confidence interval for the proportion of all patients undergoing a hip surgery procedure who develop a surgical site infection. So we want a 95% confidence interval for infections, or for patients that get infections. Okay, so remember the formula that I wrote on the first slide is p hat plus or minus z alpha over 2, and then square root of p hat 1 minus p hat, and then over n. Okay, so it's pretty much very similar to the thing you just calculated. The only thing that's really different in your confidence interval is instead of a 3 here, you're using z of alpha over 2. So remember, the first thing that we need to calculate is z of alpha over 2, and remember how to do that. So for 95%, we're going to get an alpha equal to 1 minus 0.95, and we get 0.05. So we have an alpha equal to 0.05. Don't forget, this is the thing you must not forget, is to divide alpha by 2. Some of us in class today, we were forgetting to divide by 2, so we do that, and we get 0.025. So then we're looking for z of 0.025, and you can do one of two things. You can find 0.025 in your normal table, so you can use the normal table. Or now that we have this amazing t-table, if you look at the t-table at infinity, you should get the z value for 0.025. So you'll use the t-value at infinity. I think it's on the second page of that table for the t-table, and you will get that z of alpha 0.025 is 1.96. So either way, there's a few ways now you can calculate that, but you should get z of 0.025 to be 1.96. And so now all we need to do is use the p hat from the first page and the n from the original problem and this z, and all we have to do is plug all that in and get our calculation. So if I start plugging stuff in, I'm going to get 0.013 plus or minus 1.96 square root 0.013 times 0.987, and all of that is divided by 12447. So now all we have to do is just calculate this out, and we will be finished with the problem. So I'll start one more page to do that calculation. We'll write out our final answer, and we'll know what we need to do. All right, so we had all the numbers on the last page, so the only thing we now need to do, so we had the 0.013 plus or minus 1.96, and then that p hat business we'd calculated in part B, so if you go back and look at that, I believe it was 0.001. So if you use that in this formula, that should be the correct square root of p hat times 1 minus p hat over n. And if we calculate all that out and get our upper and lower bound, we're going to get 0.01104 and an upper bound of 0.01496. And this right here, right, will be our 95% confidence interval for p hat. And that is what you're looking for in these problems. And all these problems will be very similar, and that will be the process that you'll follow.